Thank you, Marie. Appreciate it. And thank you, everybody. Appreciate the opportunity to present and kick off some very interesting startups today. Let me give you a quick overview of Select and who we are. And I've got a multitude of... Here we go. As Marie mentioned, John Andrews, CEO of Select. Select is a predictive analytics, machine learning technology company. We are primarily focused on retail. There's been some conversation this morning about the interaction of AI and machine learning with humans, and I think in retail this is one of the most interesting areas of this. Specifically in one of the areas we've had the most success within retail apparel and footwear, where it's very much about an art form of choosing the right products. But what we're seeing as retail is going through a pretty significant transformation right now, that's changing, and retailers are looking to bring more science to that art of retail. We are working in some other verticals with the core platform of our technology, and more generally thinking about how we bring science to that art of decision making and help individuals within their day-to-day jobs answer the most valuable and important questions with the highest ROI. But I want to give a very specific example to you today in terms of what we're doing within retail. And let me take a quick second to set the context of what the problem is. And let's take one of our customers is Saks Fifth Avenue, and let's take the example of how the buying team buys shoes, right? They spend $600 million annually in terms of what they're going to spend on inventory to bring shoes into their stores. In order to do that, they need to find 90,000 shoe types, style, color, size combinations. And it's not just an individual shoe, right? It's the assortment of those shoes, it's the quantity of each of those shoes, and it needs to fit in with the assortment of all the other products that they have within their stores. They might have hundreds of stores, they've got wholesale partners. This is not just a stores problem, this is also a problem in terms of online as well, and understanding that demand coming from online, where they may have millions, hundreds of millions of customers potentially. And you've got constraints at each step. Where they have $600 million, maybe they need to do $2 billion in revenue in shoes, and they'd like to have $800 million, right? They only have so much space within a particular area. The challenges here is dealing with this complexity while proving for two things: being able to avoid stockouts and avoid markdowns. And the way to do that is to be able to predict and understand true demand within that environment. The way that this is done today is heavily based on gut instinct and heavily based on Excel spreadsheets. And the reason for that is because there hasn't been good technology and the scale and the science to be able to deal with this complexity. One of the challenges here is what we refer to as the sparsity of the data within retail. They're going to start with the data that they have in terms of transaction level information. This is great, but if you were to take this transaction information and blow it up, where you put on the top all the different products they've ever sold, down the side every customer they've ever sold a product to, it's going to look like a big white spreadsheet, as you see here, right? So you actually have very limited information about an individual customer and how that customer is interacting with the products. And specifically with a particular product that at the end of the day, you're trying to identify the likelihood of a particular customer to buy a particular product. Now, there's opportunity here. Our company was founded out of MIT by a couple of MIT professors who had been collaborating on a lot of research in terms of understanding customer choice. And what this does when you understand customer choice is it gives us some context to the decision. Let me give you an example of that. I mentioned the transaction level information, okay? Every retailer is going to use that transaction level information to help them optimize their inventory in some way, to help them personalize the experience. But what if you knew, in addition to what that customer bought, what if you also knew what was available to them when they made that selection, right? What if you knew what their options were? Said another way, what if you knew what they didn't buy in addition to what they bought? You now have context of that decision. And there's a whole host of data, both internal and external, that can be brought to bear and help the machine learn and help understand the context of every customer's interactions. You can look at online browsing data where you can see how many product detail pages a customer goes to, and then which of those they might put in their shopping cart. And leveraging this, we can build up a very robust model that helps us answer the question, not just what did somebody buy, but rather what would somebody prefer to buy if given the choice across an assortment of products, okay? And now with that model and being able to predict and look forward, potentially with products that have never been sold before, if we go back to the apparel example in shoes, there's a new shoe that's coming in that has never been sold before. You have very limited data. With this model, we're able to build up a mathematical model of that new product and then be able to project forward to understand what demand will likely be. Now, where we focus this is very specifically on the problem of inventory optimization, which at the end of the day is the most fundamental challenge that our retailers have. What products should you bring into inventory and where you should spend your inventory dollars, and this we do it within plan optimization. A very specific question around buy optimization, which is, okay, I'm going to bring this suit into my stores. How much of it should I buy? And understanding that across demand, across all different touch points. Where should we put those products based on understanding the foot traffic of customers within particular stores? And then many customers doing ship from store, where will we fulfill those products from? So very specific, focused on this idea of inventory optimization. And I will leave you with just a view of a number of the customers we're working with today, with 2 seconds to spare. Thank you.
Thank you. Thank you, Marie-Therese. As she mentioned, my name is Arlene, and I am the CEO of Multimer, which supports better design, spatial design based on human decisions. And it's really a design that distinguishes us as human beings from all other species on this planet. We design buildings, cities, infrastructure so significant that you can see it from space. But this kind of large-scale spatial design isn't easy, which is why we design maps like this one to support the organizing process. Maps help us to plan citywide events, advocate for slum dwellers, get somewhere safely, build out a workspace, and even explore virtual worlds. But all of these conventional maps, they usually don't tell us a whole lot about the people in these places, and we've seen how this can lead to inefficiency, inequality, and sometimes even injury. So with its insight on spatial biometric signals, Multimer provides the tools that customers can use to support human-centered, data-driven decisions. In New York, Multimer's quantified stress data showed the hot spots where traffic collisions were 3 times more likely to occur. For the Associated Press, Multimer showed that the placement of your hands can really impact your experience of VR. And here in London, Multimer worked with Sustrans UK to show the relaxing routes that were 30% safer, the newer routes that were 30% safer. Sustrans has used surveys and interviews to monitor its customers, but they don't provide a whole lot of time and location context. For Sustrans, cellular data was difficult to obtain and could be quite expensive, and social media data was often biased. Sustrans saw Multimer, their New York work on the Discovery Channel, so they got in touch with us to see exactly how we do it. Just like you can order a genetic test kit to understand the signals in your body, you can order a Multimer kit to understand the human signals of the population around you. For a customer like Sustrans, an initial kit consists of 10 biosensors, including heart rate straps, and MindRider, our custom ergonomic brainwave sensor. Sustrans then logs on to our study designer to determine the sample size that will cycle through this kit and contribute through their own biosensor data. And then they recruit data collectors who will contribute and record real-time biosensor data. And I can demonstrate all of this recording technology at our booth. Back on the Multimer analytics platform, Sustrans can then see all the data aggregated spatially in real time, and they can benchmark it against other relevant areas like other cities and perform geospatial analytics with that biosensor data. Multimer grew from my graduate research at MIT and from the hard work of a team who's not just experienced in tech management and design, but also has demonstrated a reflective curiosity about many kinds of humans in this world. And with the support of some great investors, funders, as well as the privacy and ethics oversight of a number of review boards, we've extensively tested our system with select partners. So our current projects include work with UN Habitat, the World Urban Forum, to monitor new infrastructure, cycling and otherwise, in Nairobi and Kuala Lumpur, evaluation of Silicon Valley tech spaces for Unispace and the Center for Positive Organizations, and work with Abstract Group to evaluate customer experience in airports, both on site and in virtual reality. And if you want to see Multimer data in VR for yourself, you can check out the recent New York Times 360 video about Multimer and some of its data collectors. If your organization is interested in evaluating new ways of how customers can experience place, please come talk to us later. Ultimately, with Multimer, spatial designers and analysts aren't just mapping places, now they are mapping human signals too. They've been seeing for a while that all kinds of human signal data is out there, but no one is really collecting or analyzing it at scale until now. And they're really helping to build a future in which better spatial design is based on human signals. Thank you.
Thank you. So it's a pleasure to be here today. Our MIT connection is actually our founder and CEO, Tor Jakob, who is here in the audience today, but he hasn't quite recovered from the number of medals won by the Norwegian Winter Olympics team to come and stand on stage yet. Anyway, at Arundo, our goal, we're looking to transform heavy industries with assets through data-driven insights. So this is bringing machine learning to industries like oil and gas, mining, maritime, utilities, renewables. And what we're doing is we're providing software to bridge the gap between data science and operations. So we've heard a bit today about human-AI interactions and about context around data. So the data scientist has the knowledge to build the models, understand what algorithms to use to get the best insights from data. But on the operations side, you have the people who know what's the context of those data and what are the decisions they need support in and how transparent those decisions need to be. So clearly there's a bridge to gap here, a gap to bridge, and this is what our software is doing. So we're providing data ingestion, breaking open the old historians and bringing data directly into the cloud. We're allowing the data scientists to deploy their model onto those data to give real-time streaming data analytics. And we're allowing model management to apply those models across several hundreds of assets at scale, and then integrate that into existing operational interfaces to allow those people in operations to make their decisions based on the output of the analytics and the machine learning, and then to give their feedback into the system to allow those models to retrain as appropriate. So the pieces that we provide for that is an edge agent software which sits down on the asset that's connected to the cloud and is streaming the data. Then there is our composer piece, which integrates into the data scientists' existing workflows, allows them to deploy their online models in minutes, auto-renders an interface front end for them and the operator to interact with and test out, and allows iteration with users. We have the cloud-based Fabric platform, which provides the model management, connects the models to the pipelines of the data, and allows preliminary examination of those outputs. And then we provide extension applications to connect those models into the operations interface, allow the operators to provide performance feedback, and initiate adaptive model retraining as appropriate. So if you think about model deployment into operations in a typical, say, proof of concept data science process, you might find yourself in a scenario where your data scientist has trained the best possible model, has gone to the executive suite, given a presentation in PowerPoint, and said, my model will do exactly what you asked me to do it. But now you have to get that out into the field. And that might take a whole load of people from DevOps to IT and that may be 3 or 4 more weeks. And then it gets to the operator, and the operator finds that the model was not actually what they wanted in the first place. And so now the whole process needs to iterate. And if that's going to be a month process, the iteration is not going to be efficient, and you're going to fail. So the path to success here is to be able to use these kinds of software that we're developing to do these things in 5 minutes and not a month, be able to be agile, iterate, and then be scalable and adaptive when necessary. So we've worked with a lot of major customers in a range of industries, both from the asset owners, those who have the data and want to deploy these models and connect their data science teams and their operations teams. We also work as providing analytics pieces to existing platform infrastructures. DMVGL's Veracity platform has us as their analytics piece. And then we work with the original manufacturers of these equipment so they can provide service as well as physical equipment. And so I've got a quick case study around a pump manufacturer that we work with. So they want to grow through technology differentiation. And part of that is a digital service capability. So it's not just building a piece of equipment, sending it out to an operator, not seeing it for 2 years, and then getting it back and not knowing what happened to that piece of equipment in the meantime. It's about having that piece of equipment connected through an edge agent, having the data stream to the operator as well as the asset owner so that they can see what is happening to the equipment in real time. When it comes back for service, they have the full history of what happened with that equipment, why it needs service, and so on. And then they can develop the smart applications to deploy down to that edge agent and run things like anomaly detection or condition monitoring in real time. And so that's taking these old business models, it's bringing the analytics piece in, and it's enabling new business models for these manufacturers. And so those are the types of partnerships that we're looking to foster. Thank you.
Thank you. So I'm Eduard Vázquez from Cortexica, which we are spun out from Imperial College, on that side, several years ago. We are now, during all these years, we have established in a couple of verticals. Retail, mentioned before, going now into manufacturing. But what I want to talk about here today is another application we're doing that is about personal protection equipment. This is about security and making sure that people are wearing the right equipment in specific areas. Can be pharmaceuticals, can be manufacturing, anywhere that a particular equipment needs to be worn. Now, the solution we've been establishing now, I'm going to go here very briefly, is about a system that it's been already being, I'm not going to say live at this stage, but demoed successfully with some of our clients, which lamentably I can't mention, where usually people are wearing gloves or hairnets or helmets with air defenders, you name it. And right now, this is a little bit clunky how in several dangerous places, people are wearing all this equipment, which is necessary for their own safety. Where people are just wearing all the stuff, they're putting it, they check themselves in a mirror usually, in some of the cases, and off you go. So there is no actual control for all this. And of course that leads to problems, not just of health and safety for the workers themselves, but also in specific spaces for contamination, basically, if we talk about, for instance, pharmaceutical applications. Now this is of course a problem that leads to, well, the loss of a lot of money for several reasons to these big companies we're working with. And that's a problem we're tackling here. At this stage, we are partnering with Cisco and Innovate UK in a POC that leads toward, and this is something mentioned before, one of the things we've been during all these years specializing in Cortexica is really to go from what is a theoretical application, something that works on that paper, on that program, on that, you name it, and have something that really works in the real world. And there is a massive gap between one thing and the other. So for the last 3-4 years, we've been specializing and working with a lot of people who are specifically to make things work in the real world. Because on the paper, many things work, isn't it? So This is our last effort to make a new product that can be rolled out. Problems here, of course, are the fact that these gloves that maybe one can wear in that location, they have a different color, different specification someplace else. You can localize a hand with a glove, that's okay, but what about if it's not correctly put? You see some skin there. And there's a lot of small things that you need to think about, how you can make sure your system works in this environment. You don't want a 98%. So this is all about redundancy. This is all about a large number of things that go well beyond applying, in this case, some deep learning real-time, if you like, methods. This is relatively, and I say relatively like this big, but easy as compared to make things work in the real world, right? So this is where we're focused now with Cisco. It's important, of course, for these real-world applications to partner with people who can offer good hardware and good technology. We're not a hardware company, and we're not pretend to be so. So this is this project also with the UK government involved. And basically, it's called AI Safe. Again, this last thing we're doing for security and health and safety is basically what I said. It's this, working in several locations in UK, making the system that it's already being demoed with some of our other clients to basically have a product that we can roll out properly and commercially. Another very important bit, of course, as I said, there are several types of gloves, several types of helmets, several types, of all this. So how can you actually make a product that's going to work in the real world that is not out of the box? Because, of course, every single location is going to have different things. The questions we're answering here now is how people can make their own training of a system that can work basically off the shelf in a very different environments. And this is what we're offering with Cisco right now with this product. And yeah, that's pretty much everything from my side. Thank you.
Yes, unfortunately, my good putting days are a very long way behind me. Good afternoon, everybody. I'm Henry Oakes, and I'm a recent graduate of the full-time MBA at Imperial College here in London. And I'm now the co-founder of a startup called Track, which I'm delighted to tell you a little bit more about today. So just before we get started, just by show of hands, how many homeowners do we have in the room? Homeowners? Well, okay. So something that's taken as a given here in the UK is that in addition to liking to drink tea, we are also obsessed with the values of our properties. Now, during our MBA at Imperial, my colleague Byron and I got really into the housing market and consumer behavior within it. And particularly, we were interested with this fascination with house prices. People that we spoke to said that as likely to be the biggest asset they're ever going to own, managing property finances is a really important thing to them. But currently, managing property finances results in wasted time, frustration, and in a lot of cases, missed opportunities to be better off. So why is this the case? Well, after extensive research, we found that the reason people want to find out about property prices is that they want to make and adjust plans for their future. So they're asking themselves questions like, how is my biggest investment going? What property could I afford to upgrade to? What's my loan to value rate now? How much is my share worth now? Now, to answer questions like this, 3 pieces of information are required. Of course, the property value is pretty important, but the property value alone is not actually that useful. In addition to the property value, I also need to know about the debt in the property and about whether anybody else has a share in the equity in the property. So, for example, this could be a partner a lot of the time, or increasingly nowadays, it could be the bank of mum and dad who are increasingly help funding deposits for houses, or even in the UK, the government via help to buy schemes. So in addition to the property value, I need to know the mortgage details and the ownership structure. Now, the people that we spoke to said that it's the process of collecting this information themselves and turning this information into something useful that's currently a bit of a headache. Here's the current process. The best case starts off with an online valuation tool. Now, here in the UK, this might be something like Zoopla. Now, bear in mind, this is the best case. The worst case scenario involves talking to a real estate agent, which involves talking to a real estate agent. The next step is to log into an online mortgage account to get the outstanding mortgage balance. Now, once I've got the estimated value of the property and the outstanding mortgage balance, I can then do things like make a loan-to-value calculation, which is the thing that's really useful. And the people we spoke to said that they would tend to do these types of calculations in Excel, where they can, for example, look at changes through time and potentially, if they're competent and confident, make forecasts into the future. But the long story short is that people told us that this process is slow, tedious, and error-prone. But I think most importantly, it's completely out of whack with modern experiences modern expectations for customer experience. So here's our solution. Track is the clear way to manage your property money. It's targeted at a millennial audience, and it's got a stripped-back, clutter-free design, mobile-first, only showing the most important data at any one time, giving people one clear financial view of their biggest asset. We then combine this. We then take an accurate valuation of the property, combine this with the mortgage balance and the ownership structure to give the real-time valuation of your share in the property. But we then start to do cool stuff, for example, like helping people to plan with future projections and also give them tips and insights to make them better off. For example, we might be able to tell people what house they may be able to afford to move to were they to start overpaying their mortgage now. The tech that's driving Track is our ability to source, aggregate, and synthesize 3 pieces of data that are currently siloed. We do this via working with the most recent open banking standards, which are here new in the UK to allow us access to financial data. We're also using advanced machine learning algorithms to value properties accurately. So why is this interesting? Well, helping people to plan maybe sounds a bit boring, but I tell you what's not boring is learning about people's future intentions. For example, we could ask the Track database to help us predict demand for refinance mortgages in the case that interest rates are to go up in future. Or we could ask the Track database to show us everybody in London who lives in a house worth more than £500,000, who has high equity in the property, low cash, a desire to renovate, and a great credit score. Now, it sounds to me like this imaginary person would be a prime target for a home improvement loan. So why are we here today? Well, we're an early stage company, so we would always like to talk to anybody and everybody who wants to hear about what we're doing. But particularly, we're interested to talk to financial services companies with an interest in learning more about what their customers plan to do in the future to help them better target advertising and products. We would also like to talk to anybody who's looking to do partnerships with innovative companies like us in the space. So with that, we look forward to speaking to you later. Thank you.
Thanks a lot for the nice introduction. And okay, Ukwon is a spin-out of Imperial College of London, comes from the Uncertainty Quantification Lab that I'm leading, and as you can guess from the name, we quantify uncertainty usually. So we got a lot of companies where we work with, and the idea of the college, after we discussed together, was like, okay, why we don't try to spin out a company and to see if you can deliver this kind of technology to a bigger market, not only to aerospace. And this is why we got this kind of company with a terrible name, Ukwon, and that I'm here to present today. So, yes, next, good. So, this slide is about our problem, okay? There is a big issue, like we cannot think about everything. We have a lot of unknowns during the design process, okay? Our bread and butter is engineering problems. Also, we have a lot of data that are affected about uncertainties, and also we believe that about 40% of the time that you spend designing is wasted, okay? It's not my numbers, you can find a lot of reports about that. It's really wasted, not really. Here I'm lying a little bit. Because when you waste this time, you are learning how your system is working, okay? Like you learn how to become a real designer. But anyhow, let's imagine that this gives you a cost about 12% of your design process. And what is our solution? Like to summarize, our solution is to combine data and the simulation, okay? Because we are not like a social scientist, but we are engineers. And so our goal is not just to deal with data, but we want to deal also with the, if you want, numerical models. I have my design, I have my virtual environment. Why I cannot leverage my digital twin in order to get more information about how my system is going to perform? And this is Ukwon, okay? Forget about the interface, it's just for marketing. We don't really need this interface. But the big point is that we can reduce mistakes. So when you design, you reduce mistakes. You can design if you don't know data. So if some data are missing. we can improve the performance and we save development time. This is something we do every day. And we do that for critical applications, okay? So this is a lot of data, to be honest, even too much for my taste. But in terms of solution, let's start from measurements. Let's imagine you build an engine or you have an aircraft engine, a car engine, doesn't really matter. You can extract some data. We don't deal with big data, okay? If you want, we are a scarce data company. When we have 10 points, for us is a lot. In aerospace, 10 points cost a fortune, so we need to deal with them. We play a little bit with the data, with some techniques that we have an IP on that. And we use the digital twin in order to have even more piece of information. Combining real data, combining the digital twin, we can get some kind of information. What is the most important parameter, when your design is going to fail, what is more critical, and so on. But in this loop, there is an artificial intelligence machine, if you want, an active learning technique that is learning this kind of design process. And so it's somehow helping your designer to learn what's going on. This something is not in your company. One of the biggest value in your company is the designer. Why? Because he knows it's your product better than all design rules that you have. And that, if you want, is a closed loop. It's highly simplified. It's not simple as that. Good. So let's start with some good example with an exciting customer that I will call customer A. We are not allowed to share who is he, but we are in UK, is a supercar manufacturer. So like you have few names that you can think. So we build for them, we are building for them a virtual assistant. You can imagine a kind of Siri for engineering, okay? I mean, people working with me like this idea. I don't, but you can imagine something like that. We can imagine a deep learning from CAD. So you have a lot of simulation and so on. You have an assistant that is learning from your simulation and is combining this stuff with track data, with real data all together. We don't really mind if your data comes from a simulation or come from experiments. For us, it's more or less the same. And we work also with other customers. Another one is very big, but again, I cannot name it. It's in France. It's a manufacturer, guess who? And they are not building apples, anyhow. So it's a simulation assistant again. So they are predicting performance on the flight. They don't want to run simulations, okay? They say, okay, I don't want to run any more simulation. They're expensive. It's a waste of time. Can you help us with that? Yes. It's something we can do somehow. If you come to our office, I give you more details. I'm aware that I don't give you so many details at this point. Anyhow, good. So trust me, like where we are and what we need. Like we got a lot of awards and funding, so I hope we know what we are talking about. We have been named one of the 7 best deep science startups in the world, so I believe it's good. We got some funding, and now we are part of Founders Factory, that if you want is a kind of more than incubator in London. There are also investors and so on. So we are part, if you want, of a bigger community. And why we are here today? Like, first of all, because they ask us, and second one, because we are looking for partnerships, okay, as usual, like if you want to be part of us, we are more than happy, and customers. So if you want to use our products, I'm more than happy to talk to you, and feel free to come to our office. We have an office now in High Street, Kensington, and I don't pay the rent there. Thanks so much, guys.
Hello. My name is Maya Pindeus. I'm co-founder and CEO of Humanizing Autonomy and a recent graduate of Imperial's Innovation Design Engineering program. So what we're doing is, developing natural interactions with autonomous systems and allowing an autonomous system to understand and being able to predict human behavior from a human-centered point of view, if you will. Cities are extremely messy, they're dense, they're confusing, and things may change in a split second. That girl in a red shirt who's raising her hand, well, we understand that she's probably saying, thank you, I'm going to cross the street. In a different context, it might be a police officer raising a hand, stopping a vehicle. The way our sensory inputs, us humans, are really conditioned, we really understand the sequence and the context of things that are happening. Where a human driver is able to understand and predict what another human is doing on the street in a split second, an autonomous system has huge troubles with that. So this is one of the major barriers of autonomous vehicle development, especially looking at urban deployment and dense urban environments. Pedestrian intent prediction and detection has come a long way. You're able to understand, here is a pedestrian, maybe analyze bulk movements, but the complex communications that happen, the negotiations that happen on an everyday basis between humans and drivers, they're largely neglected. And that obviously brings problems from the deployment and adoption rate, but also from the societal acceptance and trust from the public in terms of if they would be able to trust an autonomous vehicle. Well, our company started off at Imperial College, actually, where we developed our the first prototype, which was a London-based data set collected of visual data here in London, who allowed a person to communicate with a vehicle, understanding and analyzing human movement, human gestures, in order to create two-way communication. Because we think what is really necessary is to create a platform that allows for accurate human intent prediction. And human intent prediction meaning culture and context-specific prediction. We're using embedded vehicle sensors by using a deep learning approach, creating deep learning models that understand human movement, human attention, distraction, and the actual human behavior when about to cross the street, to then inform the autonomous vehicle whether the likelihood of crossing or not. And what's interesting about that, or what we think our approach is unique, is that we combine very much data-driven approach with behavioral models. As I mentioned earlier, we think that behaviors in different contexts, in different cities, in different places, even in different places within a city, are very different. And that's why it's important to fuse behavioral and psychological models of human behavior, how humans are likely to behave, with deep learning models. And while I'm talking about autonomy, full autonomy right now, but it's not only full autonomous vehicles that will benefit from the solution, from the system. It's advanced driver assistance systems, large semi-autonomous technology, which already embedded in most of vehicles today, and in 2 years' time, EU regulation will make advanced safety system compulsory for every new vehicles that would benefit from a pedestrian human intent prediction on the way towards full autonomy. And yes, so what we think, as I mentioned earlier, what we think is very much needed is beyond, just look beyond, here's a human, here's a pedestrian, here's a cyclist, here's someone on the street, but actually, what is your intent to cross, and what are people actually doing? Well, we're exploring this in multiple ways. We're engaging in pilot projects to explore multiple use cases. And one thing is the full autonomy scenario, working with OEMs and other automotive partners to make our technology applicable to full autonomy scenarios. On the other hand, there's development partnerships that are about feeding this technology into advanced driver assistance system, into semi-autonomous technology, and see how can this be brought on the streets as soon as possible. And on the other side is largely academic partnerships, where we're working on these behavioral models, on really understanding how people are behaving, how people are likely to behave in different locations, analyzing large scales of data for that. So if we're looking for the partnerships, if you're interested in either partnering on the academic side, on the behavioral side, on the high side, or would like to explore human intent prediction in a commercial use case, whether it's automotive or even other verticals or adjacent industries, come talk to me afterwards. Thank you.